Welcome everyone. My name is Deborah Miller and I'm here to talk to Dr. Regina Leffers from Indiana University, Purdue University, Fort Wayne. And we're going to be talking about a project that began almost a year ago. And it's a green build project in cooperation with Habitat for Humanity and some other folks. And we're going to be talking about this project from that's been a year in the making, and we're finally getting to the point where we're done with it. Dr. Leffers?
First of all, before I say anything else, I'd really like to thank Deb Miller, my partner here today. She actually has done the editing and directing for this DVD and provided the professional quality that it holds. We're very grateful to her. So you can actually find her on the internet if you need professional services yourself to produce a DVD. She's available, and you can find her by looking her up on the internet at www.deborahmiller.com. So with that, I would like to also describe for you just a little bit about what you're going to find on this DVD. We've broken it up into segments so that you can use this in trainings for yourselves, whether this is a Habitat for Humanity staff meeting or volunteer meeting, or anyone who needs to learn how to put a sustainable residential construction project together. So on the DVD, you're going to find in general, there are a number of different segments that you'll discover on this DVD, and the main ones are these. The design charrette is shown as clearly as possible and with as much material as possible, so that you can discover, hopefully, how to put a design charrette together yourselves. If you want to do that, it's a very important aspect of a sustainable construction project. That should not be left out of any project at all, because it's the place where you get the creative answers to the individual site itself, to the specific site itself. So that's where those kinds of issues get addressed. And so that's one main segment of this DVD. Second segment of the DVD is the students' final presentations. And in that segment, you're going to actually hear about the choices they made and the different aspects of this house that make it sustainable. The very important aspects, and you'll hear some of the reasons why they made the choices they made. So that's an important aspect of the DVD as well. And the final part of the DVD contains a photography. The photographs show from beginning to end, from the just looking at the site and marking the trees for what kind, identifying them, what are they, to the very end where we've got the dedication of the house with Habitat for Humanity, and the final the new owners receive the key. So it's a very beautiful photography of what has happened with the build.
Thank you. And also, we want to make sure that you understand that the pictures that you're going to see in the videography that occurred, all of the pictures were done by volunteers, whether they were students or folks who were associated with the Access TV channel here in Fort Wayne, Indiana. So the photography was brought to you by the same kind of folks that helped build the Habitat House, the volunteers, and we think that's an important message to get out as well. Now, if people want more information, they can contact Dr. Regina Leffers, and I'll let her tell you how.
Okay, so just go to the IPFW website. That's Indiana University, Purdue University at Fort Wayne, and click on Research, then Centers of Excellence, and go to the Center of Excellence for the Built Environment. My email address is there, and you'll see it on the cover of the DVD as well. You can email any questions to me. I'll be happy to respond.
Thank you, and we hope you enjoy the video.
I'm Dr. Regina Leffers, Director of the Center for the Built Environment at IPFW in Fort Wayne, Indiana. And I'm also a construction engineering technology professor. Seniors in the Construction Engineering Technology program have been working on a project for the last year. It's the Senior Capstone Project, and they work for 2 semesters to design and then build a sustainable residential home for a Habitat family. I have three students with me that I would like to ask them to answer some questions for me. Could you please talk about who is collaborating on this project?
Habitat for Humanity, Northeast Green Build Coalition, and IPFW students in the Construction Engineering Technology Department are all collaborating on this project. They've come together to create and capture the process of designing a sustainable home. The Northeast Indiana Green Build Coalition has brought their expertise into the classroom. They also participated in our design charrette, which involved architects, engineers, and other professionals from the construction industry. As a senior in the 2-semester capstone design course, I'm happy to be at the forefront of knowledge, and I'm a part of this project.
Okay, thanks, Jen. Anna, could you tell us about the family that will be buying this Habitat home?
The family is the Belloc family, and they are refugees from Burma. And Fort Wayne actually has one of the largest populations of Burmese people in the United States. And one of the most interesting things that I learned while talking with the family, trying to get an idea of who they were, was that we found out that for a while they were in Burma, they actually lived in the jungle. So in one sense, they're going from one type of greenhouse to another type of greenhouse, which is kind of an interesting idea. And Mrs. Belloc also told us about her work here that she does, and she is a translator for the Fort Wayne Community Schools. And she also is on call at all times for the Burmese people to call her if they need translation in an emergency situation. And it's been a great pleasure to help put together a house for such a community-oriented family.
Thank you, Anna. Erica, can you explain why we're making the DVD?
Yes, Habitat for Humanity has built sustainable homes in various locations, but unfortunately, due to the changeover in staff, the process of designing and building a sustainable home has not been retained. Habitat for Humanity would like to build sustainable homes throughout the United States. We are sending this DVD out to the 1,300 Habitat offices across the United States to help them as an aid and a training tool for new employees, and also as continuing education for current employees. I am proud to take part in helping Habitat achieve their goal of building green.
Welcome back. And Dr. Villefres, can you tell us a little bit more about the design charrette, what it is, why we should do it?
Okay.
What's the important pieces to it?
I'll be happy to. So the design charrette is, as I said, it's the most important aspect of a green build project. So it's one that's important not to skip. To put one together yourselves what you do is this. First, the first and most important part of it is the people. So you want people to participate from all aspects of the construction competencies, architects, engineers, mechanical and electrical engineers. Depending on the size of the project, if it's residential, you'll want to include the homeowners or prospective homeowners. You want to include building occupants, so think in terms of that. Also, other people like interior designers, landscape architects, as many diverse of a population as you can get for the design charrette is helpful. And think in terms not of making sure that you've got people who are knowledgeable, but the reason for diversity is to get creative solutions to the brainstorming sessions. So if you've got a diverse population, what happens often is real innovation can occur because people don't think in the same ways that those of us who are trained in the field of construction or architecture or engineering think. They think differently and can help us to get our thinking out of the box as well. So that's the first and most important thing. The second important thing is to think about the materials you'll need. So in the one, for the design charrette for this residential project for Habitat for Humanity, we had approximately 70 participants. And so we had tables of between 7 to 10 people. And so you want tables and chairs. You want people to be able to break up into tables and chairs and work on brainstorming different aspects together, different designs together. So you'll want to supply each table with a large number of white sheets of paper, large white sheets of paper. You also want to supply each table with large numbers of colored markers. Colored markers just stimulate creativity, so you want that, and you want a sense of and a feeling of playfulness at the table. And often the colored markers will help that, and if they smell good, if orange smells like oranges, that's even better. So you want to supply that kind of those kind of materials. For each table, you also want to supply a site survey that actually notes where each tree is and what it is. So if the property has trees, you want them marked and you want to know where they are so that you can, when you think about the site, you can orient the building onto that site in such a way that it accommodates whatever trees you want to keep standing. And another critical piece of information for each table is a topographical map. What's around this place? You want to be able to see the site in a situation, so you can do that from Google Maps. However, there's all kinds of ways to get that information from the web. So that's a second thing. And then let's talk about the order of the design charrette. So first, you want to actually set the goals or have the owner identify the goals of the building project. So if you're setting the goals, you want to identify what's most important. So do you want to build something that will take no energy from the grid at all, that will supply all of its own energy and recycle all of its own waste, or what percentage do you want to get to in that? The second thing is to educate the people. So not everybody there will actually understand what sustainability is, and it also helps to just refresh people's knowledge, and it helps them to understand what kinds of things need to be addressed. So you want an educational session. In our design charrette, the students had done individual research projects, and they gave their research presentations on different aspects of sustainability first at the design charrette. So that's a good way of doing it if this is a classroom viewing this material. The next thing is to brainstorm, and brainstorm first the different topics that need to be addressed by the tables of folks. So brainstorm first the topics. We didn't have that much time, so we didn't brainstorm. What we did is came with a list of the topics that needed to be addressed or thought about. And we just read the list to the folks who came because it was the quickest way of getting that information out there. Then each table works together. Whoever sat down together works together. And this provides a real serendipitous working together, brainstorming together kind of experience. You probably don't want to orchestrate that. You want to allow that serendipity to occur. In a design charrette, probably the most important thing is the most important thing to occur is the creativity. And in order to allow that to happen, you need as little structure as possible. So basic bones, just to make people feel comfortable enough to allow their minds to brainstorm out of the box. So you don't want to provide too much structure. You want to allow the freedom of brainstorming to occur so that creativity can occur. So after people have, you set a certain amount of time. I think we provided about 45 minutes to an hour for each table to work together. And then the tables presented their design ideas. And you'll be surprised at how much can be accomplished in just an hour. So each table presented their design ideas. In our case, the students took those design ideas and consolidated, pulled the best ideas from each different design, and came up with an integrated one that integrated all of those ideas, or as many ideas as they could, and presented the material again to one of the participants. One group of people were the Northeast Indiana Greenbuild Coalition, and so our students presented their final sort of the consolidation to them and got feedback. So it went through a whole other process after. What you also want to do is one of the steps. After you've presented the material, the design, the different designs that tables came up with, you want to then talk about the whole systems that are involved and where economies could occur. So if you've been able to create this, design this structure to utilize passive solar energy and passive wind energy in breezes, capturing those breezes. If you've been able to design so that those two things could be used, then what does that mean for the HVAC system? How do you then treat that? So that's basically what a design charrette is and how to organize it, and I hope that helps you.
It's a wonderful process, and the people that were involved were very excited to be there, and it's very obvious. So the pieces you'll see are segments that we've put together back to back on a lot of the different aspects of that design charrette, plus 3 of the presentations at the end by the participants. So we hope you enjoy it. I hope you'll be able to use the information in your own sustainable construction projects.
I tried to consolidate time here a little bit. We're running a little behind, so I'm going to try to expedite a couple of sections here at first. So I'm going to just read my 2.5 pages of ideas. In random order, use rainwater collection, shading, summer shading, winter buffering, collection of natural winds for ventilation, using the earth temperature as a heat energy source, using possibly a waterless urinal that uses no water, Heat pump, we've talked about already. That's a given for the project. A composting toilet, a toilet that uses no water. A dual flush toilet, a toilet that has dual flushes for big and little jobs. He that's always a fun one. When I go to high schools, they really like that one. The heat recovery systems, air systems, or controlled ventilation. A solar chimney. A solar hot water. A trom wall or a thermal mass, passive solar system. Photovoltaic system for generation of electricity. Utilizing compact fluorescent lamps for a lighting source. Considering this is not mentioned today, but LED technology for lighting. Using natural lighting, using the sun as the lighting source. Using recycled materials, regionally available materials. Promote the use of recycled materials, using setting the house up to recycle the contents as a living style. Wind power generation, using convection flows within the house, the way you're setting up the house so that natural convection occurs for ventilation internally, and also distribution of heat. Landscaping materials that are native, using light shells for natural lighting. This one wasn't mentioned, but we talked about roofs a little bit in different materials. Vegetated roof, Energy Star type of roof system, basically a white colored roof or a light colored roof that reflects light. Minimize the use of materials, just all materials, using them efficiently. Minimize construction waste to no construction waste. Right, Candace? Nothing leaves the site that comes on it. High efficiency windows. The window location appropriate to orientation. Minimize exterior lighting, artificial lighting off-site, so that no light is going off of the site after dark. Light sensors are controlling the light internally, so they automatically come on or off. The wind catchers, I think was mentioned, to catch the wind up high and to be able to pressurize and bring that into the home. One that was not mentioned that I wrote down was reuse of materials. You know, is there a demolition project or a building that's going down in the vicinity that we can salvage materials, lumber, components out of and reuse into the new facility? Insulative quality of the envelope, that was talked about in a variety of different ways. The ICF wall, construction, insulation values. Indoor air quality was talked about in a variety of different ways. Rain gardens. Promoting a garden area just in the site plan that you can raise your own vegetables and fruits, so you have organic food available to you to offset. Composting area on site, so that again nothing leaves the site that comes on. Natural landscaping, I mentioned no mow lawns. Permeable exterior surfaces, the concrete and asphalt. Organic, sustainable cleaning processes, you know, for the building process as well as maybe after, and them for occupying the home. Native plants I mentioned. Heating zoned in the layout. Maybe there's an inner core that the residents retreat back to in really cold weather, so that the perimeter of the house stays cooler and the core of the house stays warmer where the occupants would be living. Solar heat, just general solar heat. I mentioned solar hot water. Reduce the heat sink, the light effect of using lighter materials on the exterior. reuse of the removed vegetation. If we have to remove a tree, can we reuse it as a component in the new process? Or the grubbing of materials, can it be ground and reused as materials that are left on site for landscaping? Mentioned low shower head flow, high efficiency dishwasher, sustainable lumbering, Forest Stewardship Council program, composite lumber, whether it's engineered lumber or recycled material composites using plastic bottles or fly ash to be able to construct the ones like a Trex board or a Lifetime lumber. I mentioned engineered lumber. I'm getting close. I'm about done here. Recycled insulation materials, heat recovery units, envelope sealing, creating a tight house, controlling the indoor air coming in, or the ventilation air coming in, fly ash concrete, the slips, structural panels, no VOCs, in the house, material-wise. Possibly look at green power availability. That's a little tough in our area, but at this point, it's fun to dream. And microturbines. Talked about the power generation. There's also microturbines that are now available that you can put in your water lines. So as the water flows through the lines into the house, it runs a turbine that generates some electricity. So a lot of neat things. What I want to do when we start our charrette process, as you see, we have an immense amount of information to start to work with. What we need to do is to be able to limit that and be able to organize it into something that makes sense. We can't take every one of those things and just sort of pile it on our paper to start with. What we need to do is to be able to take a few minutes and find something that is going to be our organizing element for this design or for your table. We have to find that logic, and it's an opportunity for us to work with. Develop your organizing element for your table. What is going to be your theme or your focus for the house? An example might be water efficiency. We're going to take water, and that's going to be our theme for our design of the house. And then our next step after we do that, we'll be able to expand that a little bit further. We've got a little bit of a task because we are under a gun of time. We have until about 1:45 today to be able to put together a table presentation. Because at 1:45, each of the tables will take their information and will present it back to the whole group. And during that presentation, what our goal is going to be, I'll bring this back a little bit later again, but we'll be discussing what was your organizing element, what is your opportunity that you're basing your design on, and then the expanded version of that. How does that expand into other realms of other areas? And then we'll go back to the site plan that's on your table, and then the envelope design of how it reflects those elements as we go through.
Okay.
Or we can go a little wider. We could go to 26. You're killing the framer.
Yeah.
Okay.
Yeah, oh well.
That's another thing. Shouldn't we keep it on? Shouldn't we at least try to keep the house at 4 foot?
With ICFs, it doesn't matter.
It doesn't matter.
Because the footer's down here, and you can put hangers wherever you want in that wall to say, okay, the floor's going to be here, and it's a complete poured setup.
Heading out. You have a what?
That's like a ship heading out of it.
She wants to talking about the window looking in the back. Like if we have the living room here, usually you have a window that wants to be facing right at the back. Now it's kind of facing at an angle instead of facing straight back.
Chop the corner.
There we go.
Good on this page.
I don't see a problem with that. I've seen houses like that all the time.
Chop the corner.
I've seen where they chop the corner. A squared plus B
squared equals C squared.
So what's our, what does that give us its
What is
dimension?
that?
If that's a 90-degree angle, though.
By 34.
As long as it's a 90, because I'm not doing the sign thing. All signs.
Let's see. And that gives us pretty good south end. In the winter we'll have good south end west exposure. These are all deciduous. They're not evergreen.
So you'll have sun exposure in the winter. You can get through to the winter.
If you like, if you've got a lake, or I think even you can use a well and pump the water out of the well. It's actually, I think, the most efficient and it used to be the most popular, but because of environmental stuff, it's been taken over by the closed loop.
You'd want to keep it on the trench. Are you allowed to put it right next to your boundaries?
That's a really good insulated foundation.
Okay, all right.
So right, okay. What the point is that if you have this overhang and you've got a 3 or 4 foot high window and you've got a 3 foot overhang, by the time you come down at the highest point in the sun, you're getting very little solar penetration into the room. So the sun's
even
hitting.
Without the trees, they're going to be pretty well.
Oh,
the house
absolutely,
is going to be,
absolutely.
Well, you plan that. I mean, you know, how high is the window off the floor? How high is the top down from there? How deep is your eave? And then at what season do you want to?
Normally this is 80 inches. Most houses this is.
If the floor drains would go out into a storm storage, you still have to put a sump on it.
Well, this was capped, and you have an option. You can hook up a solar panel to it, so when it's ready to go, it got the power to go. So we don't have a lot of time. We need to focus on our.
So we want to stay away from those a little bit, or?
No, I mean, I'm just
It's 50 foot.
That's only 2 trees.
Tree outside that we can outside the setback. And we'll get the building in the setback, and what trees leave, they leave, and we'll leave the trees there that at least give you some green until you get around to
But in the
putting in
building
nicer
process, the only way we can save any trees off this lot is if it's cleared by hand.
Okay, why don't we mark that? If it's that way, we have it as a reference. As
put an
a
X on it or
possibility.
something, or darken it.
Color, use the color path that we got.
Color the whole color. What do you need?
Just
to color?
underline its name. Ash 14-inch ash. Is what I would
Highlight
think.
the ash. There you go.
Oh, that's
that works.
I think you just eliminated it.
And how's your ash been? That's an old forestry joke.
Just goofing around sketching. Pitch it so you have higher window exposure. Again, geared toward maximum winter solar radiation. So you get more winter solar radiation into a heat absorbent structure just inside of the house. Then you can increase that window. There's no reason why you can't increase it on that part of the building. The greenhouse.
Exactly.
Yeah.
Exactly.
Where?
On that.
Then you've
side
got
of the
your
building.
trom wall here, okay, and he can do whatever he wants. Put orchids in it. Put garden. Put
Okay,
vegetables.
show me what you took. Show me what.
In other words, Matt's idea of having the windows and the passive solar could be here, and then he could do skylights, he could do a wall here, and then he could have his trom wall here for storage, and then the family could have a garden out here that they could use 3 seasons out of the year.
Westerly winds come from the west, south. Put your brand name from the west. Is that the wind speed or
Here's the
probably standard?
Now, the problem we run into when we were talking about reusing lumber, so you can't do that.
How'd you put your ductwork?
You can't use
It's going to be shielded. There's almost nothing back that way. You get to the site from this way, I would say 90.
Yeah.
We can make the drive go down.
Zips is a possibility, and then like an Icynene or a foam lid with the cellulose on top.
Basically what I want to try and do, if I'm going to try and use a solar channel, is keep it in this area that this part is more open, and then put a lot of windows in this area that's shaded. All we need.
Have you found a particular hardship? Oh, these guys are all good. Okay. Back here.
Chaos! I've seen the fight twice already.
Okay, great. Everybody, the food's.
And that really has nothing to do with energy efficiency or solar. It has more to do with.
I think like everybody else is probably going to agree with you.
Where that
truss comes out so far with
well, yeah, the long narrow ones have a little one that sticks out. Usually they're about 5 by 8. And then we just pour like a 10 by 10 on the back of that patio on the back.
With the junky dirt that we excavate for the crawl space, then we could conceal the parking spot for the van and not have to take the driveway all the way back. Then we could make this. Take people places to children.
Oh.
If you could somehow bring like the driveway in like this and make it like an L shape.
I don't bring it totally like this, you know, do it skewed somewhat.
Well, yeah, there you go.
Right,
So
you wouldn't have to make
then,
yeah.
You still have an opportunity for solar. The whole point of this is that you're going to pick up.
Right, I mean, I don't know.
That's probably another habitat.
Yeah, it hasn't been built this year yet, so it'll be there.
So you got a whole parcel of land there or something that you got donated?
Well, yeah, we have a total of 42 lots out in this area, but there's 2 lots right here that we just got, these 2. These are the first 2 houses we built out in that area. There's 2 more.
It's easy to model. I just drew a rectangle and pulled it straight up. It takes like 2 seconds to make a box.
That's cool.
I guess it's made in England, but they have plugins and all this data that I pulled from the Fort Wayne.
Okay. Our table took on the approach of looking at this project from an interiors point of view, because there were at least 2 of us at the table that are involved in interior design, and some of the other people at the table are involved in, have taken interior design courses. So we really wanted to look at this house as we're developing it from the inside out. And of course, one of the famous architectural statements is form follows function. And so that's really the way we approach this thing. And so and we love this statement that our client made, which is, you know, her life is really from a bamboo house to a greenhouse, and that was a great place for us to start in terms of thinking about this design and the spirit of this, and how the house grows out of the spirit and of the lives that live in it, of the people that live in it. And that it grows up from the ground, and it grows like a bamboo shoot. It comes out of the ground and gives life and spirit to us. So our approach was that one of the ideas we came up with is we wanted to then take this house and from the inside out look at how would we orient the rooms, and orient the rooms to the sun and to the solar path, just as the sun feeds a plant, would feed the house. And then using sustainable materials. With the idea that perhaps this has a concrete slab on the floor, but you use that concrete as a patterned and stained material, and that the floor actually becomes the decorative and sustainable element of the house. Use of bamboo wherever we can in trim or in decorative surfaces. Use sustainable materials in the cabinet design. Use radiant barrier paint in the paints. Use sustainable materials in the countertops. We like the idea of bringing a light tube into the bathroom so that you're eliminating the use of having to have electric light fixture as much as possible. And of course using Energy Star appliances everywhere. Arranging the spaces so that the plumbing is back to back, and that back to our rooms oriented properly, that Therefore, you have minimal windows on the north side where there's no sun. You have windows on the south side to pick up the sun. And this back to efficiency, using low flow faucets and water supply wherever possible. That's us on the team. So here's how things worked out. In orienting the house to the sun, we wanted to get as much orientation as we could and orient the rooms. And so even though this is our site plan and it isn't related to interiors, what we ended up doing was rotating the house on the site so we could get as much sun as possible around the rooms that are in this lower area. And so coming off the street, you'd come this way to the front door, and then your back door, and then this would open up to the backyard with the garden down here, saving as many trees as possible. And then finally, as we were doing this and looking at the site, because we want as minimal exposure to the north, that we actually berm the north side of the house. Since this site is going from high to low this direction, that when we do the cut and fill to put in the house, we actually can bury the house into the site on the north side, so that we're actually using the earth to protect the north side of the house as well as the insulating materials and minimal windows on this side. So here's how the house would lay out then. Coming down around this way would be your front door. We've put the living and dining area right in here. And we wanted to provide as much flexibility for the client as possible, because they both have, they eat there, but then several times a year they expand that space and have large gatherings of people for communal meals. And so what we decided to do was we wanted to really block off the kitchen for cooking because of the cooking odors, but then open it up by having a doorway here that you could open up and kind of have this open back and forth, but have the dining here. Now, we pushed the dining into this southern corner because the eastern sun is coming this way. And so we're going to pick up the eastern sun first thing in the morning to warm up this room. And Mr. Belloc comes home from work, and that this would be the place where he could sit in the morning sun and have coffee and breakfast, and it would be the room that the sun would hit the most. So coming around this way then, we've got the afternoon sun picking up for the living room. So during the times of day that you're living, in the evening and afternoon, or having a communal meal, you'd have the sun coming in from this side. On the north side would be minimal windows, only the windows necessary for the bedrooms. We push the bedrooms to the north because you're using them at night, and so you can actually cut those rooms off during the day, and then at night you're sleeping in these rooms. Only windows enough to meet code egress requirements. No windows on the north, basically the northeast side, northeast side. Mrs. Belloc's room would be this one. So because she working there during the day, it's kind of her office and her bedroom. And so this room would be her room. And then we wanted to put all the plumbing together into one big plumbing core for efficiency. And so we've got all the plumbing along this wall, which is the eastern wall. And the kitchen, somewhere along here, we'd like to have a door to the outside. Here's your bathroom. Of course, the bathroom is accessible to the bedrooms, and then your kitchen right here. Did I miss anything, guys? Oh, that's what I wanted to say. We want minimal windows on this side, so we're taking whatever windows are allotted for the house. We want to push them all down here. So we're going to want to concentrate as much as possible down here, and hopefully we get one sliding glass door at least, and that come off the living room. And of course we want to pick up as much of that sun as we can with a sliding glass door. So there we go.
Any other questions?
All right, that was, for the record, the first thing we did was save paper. Second thing we did is drew it upside down, so you all have to stand on your heads. All right, north is down here. Yes, I did draw it upside down. All right, so what we addressed on at our table is landscaping and solar. Of course, with some of that, we had to discuss some of the house design, came up with an idea for orientation, and we wound up with actually, again, this would be the northwest corner. It looks southeast, it's not. Remember, you should be standing on your heads. All right, so what we came up with is fitting that up into the absolute northwest corner of the lot with simple orientation, very standard with a hip roof, and maximizing the solar radiation with that hip roof and adding on a 3-season greenhouse for some added passive solar. We then looked at the drive around, the driveway with the parking in the back that would be coming off of the Sherwood Terrace entrance here, back around the east side of the property and around to the back here, with an entrance, main entrance off to the side here instead of the normal, what you would usually see as the front entrance here. So anyway, what we did there is also made it so you entered into a living area great room to maximize the amount of passive solar that you possibly can in the area, in the biggest area possible. Also rendering the bedrooms, sending them to the back part of the building, so that way they can retain a fair degree of quiet, even if there is activity going on in the other part of the structure. So we figured that worked out fairly well. Because of the slope of the property, it created quite a few problems with the landscaping and also with the solar. So consequently, the only trees we retained that are currently existing are these, well, 2, and then this one being a possible 3rd. If it could be saved, we would do that. That's the ironwood. The ash here, and of course, we hope they keep the butternut. We've had some news that they may have, the neighbors, this is a neighboring tree, neighbors may have already cut that butternut down. We don't know. Looking at retaining, this is actually the 14-inch ash here, and the ash here at the other end of the property. Then going through with some additional landscaping with the contour of the driveway, wrapping around the building, putting in some plant beds with, well, specifically on this end because it's so dark, because it would be the shaded part of the house, some hostas and other assorted perennials as appropriate. And then also, again, we have nice trees up here for the forward presentation, the street side presentation. Also, the ironwood, sorry. This area over here, this orange area, is the windbreak with arborvitae interspersed with various tall grasses and other assorted perennials. That way it creates a fair amount of shade and bit more of a windbreak as well. And then leading into a rain garden, this being the downslope into the site, although stormwater is basically coming off this direction, going off this direction. Again, that would be south. So anyway, what we're doing in order to help accommodate that is this driveway is also going to act as a French drain. Those of you who don't know what a French drain is, basically it's a coarse aggregate that is trenched down to a certain level and then would be basically routing any stormwater coming on site this way around the property and depositing it into the rain garden here, as well as taking the salvage from all the other trees that were cut down. And what can't be salvaged into usable timber on site would be recycled then into mulch that we would use as an amendment for the soil in the back of the property. That to help increase absorption, infiltration, what have you. So in a nutshell, let's see, we're also looking at, with the solar, we're looking at passive solar, again, through the greenhouse and the windows, the domestic hot water system, and the photovoltaics, which we figured could all be handled here. We are placing 2 rain barrels to accommodate the 2 downspouts that we figured would all be necessary to come off the pitch of the roof. Let's see, what else? Did I hit everything? Well, yeah. What can't be used as timber on site? What we're hoping to use the timber and maybe make a front door or some framing out of the timber that is salvaged on site. And what can't be used on site or what it happens to be extra could also be sold. Well, we didn't have a fireplace. That wasn't our area. We were just talking about the landscape and the solar. So with that, anything else?
How's it going? We are group 3/4 slash the 6 shooters. 6 of us back over there. Our main focus was energy efficiency. We decided that the idea that trees, and we, our biggest, one of our big points was to utilize and try and conserve the trees in their position on the lot. However, the possibility of losing some of those trees on the south side is definitely there. So we thought that being cost efficient for this area of the city would be probably the best way to go. So we went for energy efficiency, and we focused on the envelope of the building with HVAC, and then also the orientation of the house on the lot. So for the envelope, we kind of had some issues figuring out what was best. We don't know what we can afford because the upfront cost is definitely going to be there. Of course, in the long run, it's going to be worth it, but upfront is still an issue, especially with this type of house. So we went ahead and made a 3-tier system for each area except for the foundation. I think everybody was pretty much on agreement on what we were going to do there. So with the wall system, good, better, best. I think with good was 2x6 with a bad insulation, and then of course we could change that up for an expandable foam. And then if we wanted to go real awesome, we'd go with the ICF system. For the windows, we thought we could go just normal with a bad or a blown-in insulation. Otherwise, we could do a blown-in or a bad insulation with radiant barrier. Otherwise, we could go for the best and do some expandable foam, and then also with a radiant barrier. Now, for the windows, the talk was, you could do just a regular two pane, double pane with some low E or a film or even like a triple pane window. But we decided that if we were going to try and utilize the windows for the most, their best potential, it might be a good idea to have something a little less heavy. So a triple pane, we went ahead and threw that out the window. No pun intended. And we basically just came in with the possibility of using a double pane with nothing. Otherwise, it would have a low E or a film on there. Moving on to HVAC, we went with geothermal, which has already been donated, with a Renew Air system and radiant heat in the floor and then orientation. We wanted to utilize the trees on the southwest and northwest sides of the house for this lot, with focus on windows on the south side, living room, and well, we ended up changing that to the kitchen, but oh well. Anyway, driveway. We were going to put it on the right side of the house, our left, but on the right side. However, we realized that in the winter we're going to have a lot of wind coming this way. So even though these may have no limbs on them, last year, surprisingly, a lot of the winds came from the northwest and west area in July and August. So in those months, you're still going to have leaves on your trees. So the idea that we can utilize these trees to block that wind along with putting some vegetation around the house, we thought that would be a good idea. And thus, we got rid of some of these here, and the driveway we really didn't take too much time in, but we figured, if we have a driveway for them to get their van back here, or they want to park it here or there, they'd still have a pretty long drive for them to get enough cars if they have a bunch of neighbors or people coming to see them, because from what I understand, you're going to have a lot of people coming over, right? So we also decided that it might be a good idea to go ahead and put a garden back there, and with the prevailing winds coming through, we got it. It's situated where you can have wind tunneling to the windows, and we focus those down on the south side of the house. As you can see, our layout is a little bit distorted. We got a real long bathroom, which is actually bigger than room number 2. So Anyway, we tried to keep with what might look the same with the rest of the Habitat houses. So we went ahead and kept with a front porch, and we're going to try and keep it as conventional as possible as far as look goes on the outside. Just utilize the lot orientation of the house on the lot to maximize the natural energy, along with the energy efficiency inside the house. So everything that we're putting in there is going to be used even less. So if you guys have any questions, also we put the shed down here, which also has possibility for solar, but it was opened up, and we figured that was a good place to put it. Any questions? No? Okay. Awesome.
Hello, I would like to begin by thanking everyone for being here tonight. My name is Adam Ansball, and I am a student in the Construction Engineering Technology Department here at IPFW. And as part of our 2-semester senior design class, we were given the task of designing and building a sustainable house for Habitat for Humanity. For those of you that aren't familiar with sustainable design, simply put, it is basically having the least amount of impact on the environment. With that being said, tonight we basically want to take you through our design process and to show you what we did to come up with some of the things that we have for this house. And moving on to the next slide, you can see some early stages of our design process. This is just basically early elevations of our sustainable house, and then the next slide is a 3D rendering that we came up with. And for those of you that have always thought that a sustainable house would be, too expensive and not feasible, this last slide basically shows that it's possible. We were able to build a sustainable house, and here it is. So with that being said, I'm going to go ahead and hand it over to Craig.
Thank you, Adam. As he said, my name is Craig Campbell, and I'm also a student here in my senior year. And if you go to the next slide, I'm going to briefly talk about the background of the Belloc family, and also a little bit about the design charrette that happened a while back. The Bellocs, wonderful family we got to know over the past year, and definitely was a good experience. And quick background on them, they are from Burma. They are refugees. Mrs. Belloc works at the Fort Wayne Community Schools, the school system, as a translator from Burmese into English. She also volunteers at the hospital and does the same thing around for ER and just translates Burmese into English, is on call 24/7. Mr. Belloc works third shift, and so therefore he sleeps during the day, and they have a 21-year-old son that volunteers for the church and drives a 15-passenger van. The reason why I'm telling you is this is just all kind of considerations that we took into the design charrette and the layout of the house. Another thing Mrs. Belloc always emphasized was the cooking. Burmese people, they love the cooking, she loves the food, and it's extremely spicy, but kind of smells up the house, she said, so that's another huge consideration we took into the house. And moving on, talking about the design charrette, this was a great opportunity, and for those that don't know, the definition of a charrette is a collaborative session where a group of professionals or designers come, and basically they come to draft a solution to the problem or just put their inputs into it. During the design charrette, it's a large group, and we break down into smaller groups or subgroups, and each subgroup will focus on a certain area, and at the end of the charrette we will come up with the best possible solution. And it was a great experience and opportunity because we had different professionals from around the local community and the area to talk with, and with the different trades of the professionals we got to meet with them, and they had different experiences, and it really, I think the students, we took a lot out of it, so that was very nice. The next slide. During the design charrette, we took away from it a lot of different things. the building envelope, the wall system, and as you can see on the screen right now, this is a picture of our Dr. Leffers that's holding up an ICF, which is an insulated concrete form. That is 2 inches of foam, followed by either 4 to 6 to 8 inches of concrete, and then 2 more inches of foam on the inside. This wall system will give you a very high R value, and it's one of the many wall systems that we considered for our house. We also talked about the foundations, the roofs, the interiors, what kind of materials the interiors are going to be, landscaping and solar usage. And as Adam stated earlier, that we talked about one of the main goals and objective of this was to prove to people that green build is affordable, and I definitely think we succeeded in the fact that we have sustainable materials for a very reasonable cost. So, and now I'm going to hand it over to Tori.
My focus on this project was the site. I'm Tori Ehrman. I'm a junior here at IPFW, and when we began the project, first we were just given an address, and we had no idea what the site looked like. So if we go to the next slide, we can see the aerial of the site, and that's where we began. We collecting data off of online sources. We started with Google Earth, and that's where we got this image, and that gave us an idea that the site was very vegetated. If we go to the next slide, we looked at the firm maps to find out and make sure we weren't in a flood zone and that we were okay there. Everything worked fine there, and we were clear of we were pretty high up elevation-wise. Then we began to look at our local GIS sites, and that helped us get a feel for where the utilities were, where we could access the sanitary and water systems, and where we would like to send our storm drainage to off of our site. The next slide shows a photo of the site that was taken during one of our field visits to the site. And you can see that it's full of vines and thick bush, and there were some trees in there that looked decent and ones that we could save. So we decided to survey those, and we began to inventory those. And if you go to the next slide, you can see we collected the data with pink ribbons. The species were written on the ribbons, and then we went out and collected the information with regular surveying equipment, and we mapped all that out, and it gave us our base map, which was the starting point, and we had that at our design charrette. The next slide shows the topographic survey, and that's where we began to work with our elevation and setting our building height. And it gave us a good reference point, and we were able to determine what trees we wanted to save and what we wanted to eliminate. Fort Wayne is a collection site for weather data. We looked at a lot of places and different softwares that allow us to map out the natural energy that was on the site. And Fort Wayne being one of the sites, it was easy to collect that information on the internet. One of the programs that we started with is called Design Builder. We quickly found out that the program is very capable of modeling our house and giving us a thorough analysis of how it would perform using our HVAC systems, but it has a steep learning curve. So in the short amount of time it would have taken us, we weren't entirely able to produce accurate results. We also looked at SketchUp, and that was a good program that allowed us to forecast the shadows of the clear story and how they would project into the house during different days and different months of the year.
Thank you, Tori. My name is Rashid Ahmed. I'm here to talk about house orientation. House orientation, it plays the platform for the whole design, because this is where we are starting to use our knowledge of using natural energy and prevailing energy. This is necessary because we maximize the use of our energy, and also we minimize the consumption of auxiliary heating and cooling to the house. This is the site plan for the house, and this is how we have the trees that it can help to bring the breeze and block the cool on the winter time. As we see, we have most of the trees on south side compared to north. The second slide, it shows the movement of the sun on the northern hemisphere. The sun, as usually, it rises from the east and sets on the west. But in northern hemisphere, the maximum solar you can utilize in the south and southwest. So when we design the house, we make sure that we put our big windows on where the sun is. You can utilize best the sun. So in our lot, we have the street on the north, but we did not manage it to put the entrance of the house to the north. Instead, we put to the south, so we can utilize better the solar energy. Then we come, another slide is shading. We have deciduous trees that we can use it on this summertime for shading the house, and at the same time we use it on winter because of the lack of the tree, so we can utilize the sun to the house.
I'm Mary Kopke, and I'm going to talk about the rain gardens. The first thing is there was no stormwater, there's no storm sewers on the site. So what we did is we decided to implement a rain garden into the landscape. And a rain garden is a depressed garden, and it's full of native plants such as grasses and flowering plants, and they absorb the runoff of the stormwater from impervious areas such as driveways, sidewalks, and the roof. And all the plants that we use are native, and they're perennials, which means they come up each year from the root. They also have deeper roots which hold in water, and they also prevent erosion of the soil. With native plants, there's no use for pesticides or fertilizers, so the maintenance is pretty much minimum. It is also an increased habitat for butterflies and birds, and it provides a source of food for the birds in the winter. Rain gardens, they reduce stormwater runoff by collecting and filtering the water of pollutants and before they enter the lakes and the streams. And this also helps control the erosions of the rivers and streams. Rain gardens can also prevent like wet spots. If you've ever had like wet spots in your yard, this will help collect it to a certain area, and then the wet spots will be in a mulched area. The placement of the rain garden, you want to put it at least 10 foot from the house, and that will keep it from seeping into your foundation. But you want to keep it a minimum of 30 feet from your downspouts. You don't ever want to place it over your septic system, and full and partial sun is the best placement. You don't want to put it under a large tree that would be totally shaded. The sizing of the rain garden, what we used is we took the square foot of the roof and we divided it by 3, which an average one is, you take a 1,200 square foot roof and it's 400 feet. And the depth of the rain garden is determined on the slope of the land. So we figured that the depth of the rain garden would be between 5 and 6 inches, and that's the depth of the mulch. This is actually the site plan that we have. In green is the grass we used, which was a it was a grass that was very deep rooted, and it got to an 8-inch height, and then it would lay over. And that only had to be mowed once in the fall. And towards the southwest is that pink area is where the rain garden is located. The land did slope to that spot there, so we felt that that was the best placement for it. Your basic materials you need to create a rain garden is shovels, a garden rake, hose, just basic gardening tools. The next is when you're choosing your plants, you want to choose plants that can tolerate saturated soil and also dry conditions. And when you're choosing your plants, you want to also make sure that you choose them depending on their mature height and what time of the year they bloom, and colors, because you want to make sure that you have color throughout your seasons. The maintenance of the rain garden is pretty minimum. Once a year in the fall, right before winter, you might want to remove some of the dead plants by just clipping them off. And like I said before, you don't need to use any pesticides or fertilizers, and there's really basically no watering because you're getting the water from the plant or from the roof. And once a year in the spring, you want to apply your hardwood mulch, which that will hold in the moisture for the plants, and it'll also keep weed control down. And the rain garden is beneficial for many reasons. It improves your water quality by removing pollutants. It can help control localized flooding in your area, and it encourages wildlife and biodiversity.
My name is Erica Lamont, and my focus on this project was on the floor plan. We worked on the floor plan around several issues. The first of the issues was the site. We have a very small lot, so we had to watch the size of our house to still enable these people to have a yard, put a shed, and park out in the back as well as in front. So the total square footage on our house was under 1,000 square feet. So one of the things that we really wanted to do was make sure that we could maximize the usable space that they had. If you look at the back of the hallway on the floor plan, we angled that at 45 degrees to give easier access to all 3 bedrooms in the back. And this eliminated wasted space in the hallways. Some of the other things that we did to eliminate wasted space were to put in a pocket door in between the kitchen and the living room. The family had specifically requested that that be a separate area since they cook and their food tends to smell up the entire house. So by putting that wall in there with a pocket door, we still aren't losing any usable walking space in the house. Also, with the 45-degree angle in the back, that gave extra storage space for the closets. Each of the back nooks that is actually framed in, and the drywall is in place right now, so you could put any random items back there, shoes or stuff that's hard to find space for. We try to look at shrinking down the rooms that you don't want to spend much time in, like the utility room. So that ends up being a smaller space to maximize the living room, the kitchen, and the dining. We also made the bathroom smaller and gave the bedrooms more space. The other thing that we looked at was the ceiling height. Because this is such a small house, we wanted to still make it feel large. So if you go to the next slide, you'll see that's our living room. And when you walk in there, it feels like a very large room because the ceiling is so high. And with the clear story windows, it gets plenty of light. So you don't feel like you're in a cramped little space. Those were just some of the things that we took into account when we were looking at the floor plan and how to maximize this and make this a home that this family can stay in for longer by addressing their issues, their concerns, and their needs.
Once again, my name is Adam Ansball, and there are a couple items that I would like to discuss with you now. First of all is thermal bridges. A thermal bridge is basically a transfer from the outside of the house, a transfer of energy from the outside of the house to the inside of the house, and this is done in most cases through the stud wall. Energy transfers through wood a lot easier than it does through insulation, and you can see by this illustration the blue lines there are cold coming in from the outside. And you can imagine having 30, maybe even 40 of these on the wall. It adds up to a lot of energy loss. One of the ways that we came up with to eliminate this was to do a double stud wall. And basically what this is, it's just a frame wall inside of another frame wall. And we offsetted the studs to reduce and eliminate the thermal bridge. The second thing I want to talk about are finger jointed studs. Basically what these are just 1 foot, 2 foot, 3 foot pieces of wood that normally would have been used, or not used, but just thrown away as waste. And what they are is they can be used and glued together to, make your 8 foot piece of wood. And this next illustration, you get a good visualization of how these work. You can see in the far corner that that's not even a 1 foot piece of wood that otherwise would have been used as waste, can be used now in this home as part of the stud wall. And one thing about these finger jointed studs is they're not only just as strong as your typical 8 foot piece of wood, they're also straighter. And also with this picture you can see how our double wall works. You have your outside frame and your inside frame, and there's no continuous piece of wood going from the outside of the wall to the inside of the wall, so you can have a continuous wall of insulation. The third thing I want to move on to is your clear story. The first thing that comes to mind when people think of a clear story is, oh great, you get natural light, and that's true. If you place a clear story in the correct direction, you get plenty of natural light from the outside. But another thing that we took in consideration is convection cooling with this clear story. We made these windows operable, so in the summertime when warm air gathers in the highest point of the house, you can open the clear story window and open a window in one of the bedrooms or in one of the hallways, and you get natural ventilation to release that warm air out of the house. And the last thing I want to discuss is our crawl space. We decided to put this house on a crawl space for, one reason, we needed a place to put our geothermal unit, and then another reason, we needed room to run all of our plumbing and duct work. So we decided to set it on a crawl space, and we decided to condition it, which reduced the need for insulating the floorboards. And with this illustration you can see our crawl space and how we insulated the inside of the concrete masonry units to achieve an R rating of 40 so that we could have a conditioned crawl space.
Hello, my name is Joe Gabbett, and I'll be discussing the geothermal unit. For the Habitat house, we decided to go with the geothermal unit because it is the most cost-effective, most energy efficient, and environmentally friendly way to go. Geothermal is a fairly simple concept. As we all know, throughout the year, the outside air temperature fluctuates with the changing of seasons. And in contrast, the ground temperature from 4 to 6 feet below the ground remains relatively constant, around 55 degrees. This is because the ground absorbs 47% of the heat energy that reaches its surface from the sun. A geothermal system works by circulating a water-based solution through a buried loop system to take advantage of these constant temperatures. To create heat during the winter months, the fluid circulates through the loop, extracting heat from the ground. The heat energy is transferred to the geothermal unit The unit compresses the extracted heat to a high temperature and delivers it to your home through normal duct system or radiant heat system. To cool your home during the warmer months, the process is simply reversed. Because the earth is much cooler than the air temperatures on a hot day, the geothermal system removes the heat from the home and deposits it into the ground. The fluid is cooled in the ground by the ground temperatures and returned to the unit for cooling. The cost savings for geothermal can be easily broken down. The annual heating, cooling, and hot water cost for an average 2,500 square foot home with the geothermal unit is around $780. With the high efficiency natural gas and AC unit, it's around $1,400. With an air source heat pump, it's around $1,600. With a high efficiency propane, it's around $2,300. This can add up to be an annual savings of $700 to $1,500 a year. Another big thing was the energy savings. With geothermal system, you get 3 to 4 units of energy for every 1 unit of energy you put in. This makes geothermal 300 to 400% energy efficient. A typical geothermal unit uses 20 to 50% less energy than a natural gas unit. Today, more than 1 million geothermal heat pumps have been installed in the United States.
My name's Sam McClintock. My focus was primarily on finishes for this house. For all the rough framing is done, and insulation is installed, electrical wiring is roughed in, vapor barrier is put on. It's time for the finishes. You put on your drywall, of course, your tape, drywall compound, and paint. So in choosing sustainable finishes, drywall is a pretty easy one. It's 100% sustainable. It can be used for various purposes, various recycling purposes, such as agricultural use for soil stabilization in fields, and it can be easily recycled through compost with other organic materials, such as leaves and grass clippings and such. Any compost pile can take it, and it will 100% biodegrade. So drywall is a pretty easy choice. The tape, again, it's a paper-based product, so it's biodegradable as well. But the drywall compound, most store-bought compounds, typical to what's being used in the market today, contain vinyl acetate polymers, which also contain VOCs. And vinyl acetate polymers that's the bonding agent that gives drywall its drywall compound its flexibility. The drywall compound that we chose to use in this house contains no vinyl acetate polymers, therefore very low VOCs, and it is a sustainable product. The paint we chose was the Sherwin-Williams Harmony, and the Harmony paint is a zero VOC paint as well. Therefore, I guess I should say that VOCs are volatile organic compounds that release odors into the off-gas odors into the space. This paint has zero volatile organic compounds, and of course that was a great sustainable choice. Our flooring, we chose linoleum for the hard surface areas, which is 100% sustainable as well. When it's recycled, any scraps, any waste is 100% recycled, where it uses linseed oil, rosins, limestone dust, in its manufacturing. So even its manufacturing makes for it to be sustainable as well. The carpet we chose is 25% recycled material. It's pre and post-consumer combined. The casework that we chose is rubber wood. It's an Armstrong product in the Coronet series. It is rubber wood, and rubber wood is a wood what it's used for is to extract latex as a natural rubber.
what's happening is that these rubberwood forests are being clear cut, and the wood is being burned. They're doing nothing with the byproduct of the actual latex. So what furniture manufacturers and cabinet manufacturers are doing is they're taking these trees and essentially recycling them into furniture and cabinets. So the casework is also a sustainable material. One of the reasons why we chose a hardwood as well is its sturdiness. Our countertop, which will be discussed later, is a concrete countertop, which you can understand has quite a bit of weight. So therefore, we needed a good sturdy countertop or cabinet to sustain that weight. Rubberwood also is for those who are interested in woodworking, and it also makes for the manufacturing of this. It's a very easily wood to work. It's a very easy wood to work with.
My name is Adam Sordelet. I'm here to talk about the concrete countertops. Why we chose them, there's many reasons. The first is Habitat has a theme of volunteerism, and doing the countertops, students pouring the countertops, you know, we would volunteer our time, so that is the volunteer aspect. Like I said, students get involved. Some of the other ideas we kind of, you know, just talked about it. With this, we could actually get hands-on. As Sam said, there's a lot of weight to the concrete, but that makes it sturdy. So when Mrs. Belloc is chopping up her whatever she chops up to cook, it's going to be a sturdy surface to work on. The concrete, we can add color to it, so you can get any color you want. We went with amber color. It keeps the cost down because of the students. We were volunteering our time. We didn't have to pay someone else to do this. We did it ourselves. So that saved on the labor. And the concrete's a sustainable material, and that goes along with the theme of the house. You know, sustainability. All other materials were sustainable, and concrete's very sustainable. So that's another reason why. It's something different, you know, just not some ordinary countertop. And another reason why is in the summer I pour concrete, so I like to finish it and things like that. So to me, I wanted to do concrete, so I was kind of biased towards that. There's 2 spaces where we were going to make a countertop for the bathroom. In the bathroom, we cast in place in the lab on IPFW's campus. The kitchen, which we just poured Saturday, was a cast in place, and I think I said the kitchen or the bathroom was cast in place. That was precast, and that was, like I said, done on lab. As my voice cracks, on IPFW's campus. There's just some pictures on the slides right now of us forming up the bathroom countertop. There's Adam screwing in some forms. Erica's our project manager. She was just kind of, you know, overlooking. And Sam, very thoughtful man, was just giving, you know, good job, Adam, kind of camaraderie and stuff. The bathroom, we poured upside down and then flipped it over. And so in that, we could add aggregate, and we added some colorful stones. So when we flipped it over, we ground off maybe 1/8 of an inch of the countertop to expose that egg. And it was, you know, it just brought a little more color to the bathroom countertop. And then the kitchen, we just poured Saturday, as I said. That was cast in place. That is Craig dumping some concrete in. We had a mixer outside, and we had 5-gallon buckets to bring it in. That's myself with the tool in my hands called a float, and that's just to finish the countertop. The bottom picture is Erica. I tried to teach her to do a little floating. She did a pretty good job. The next slide is them mixing it outside. It's Jen and Adam mixing the concrete. Mixer, it got a little messy, but that's just part of construction. And then the bottom picture is it drying. It's not it's going to look a little darker once it cures all the way, but right there you can just see it. the forms, we use a 1x6 form screwed to a 2x4 because we had a 2-inch overhang, or actually an 1.5 inches because the 2x4 is 1.5 inches. So we had an 1.5 inch overhang. The little blue thing in the middle, if you can see that, that's where the sink's going to go. So we use 2-inch foam insulation for our cutout.
Hi, I'm Anna Bear, and I'll be talking about daylighting, which is one of the sustainable aspects that we looked at for this house. And what daylighting is it's the use of natural light for lighting the house instead of artificial lighting, which reduces energy use. And one of the ways this is done is by placing a large number of windows along the south side of the house, because that's, as Rashid said earlier, that's where the majority of the sunlight comes through. And as you can see from the one picture, the sun is higher up in the air, in the sky, during the summer than it is during the winter. So you're not getting as much sunlight in the house during the summer, so you're not creating as much heat during the summer as you are during the winter. And another way that we're reducing the heat gain in the summer is the windows that we're using are, they have 2 low E coatings, and what that does is it blocks the radiant heat but allows the visible light to come, or the radiant light, the radiant heat, it blocks the radiant heat and allows the visible light to come through the window, as you can see from the other picture. And then this also helps in the winter because the low E coating will block the heat from leaving the building to go out to the colder air. So you're actually keeping more heat in the building during the winter from the low E coating. Using large windows on the south side reduces the amount of insulation that the wall has. One of the ways we counteracted this was we used windows that are, they have a value of R10, which means they're a highly insulated window. The average is an R3 or 4, and the larger the R value, the more insulation there is. So we got very well insulated windows, and the way that they're insulated is they have 3 layers of glass, and in between those layers is krypton gas, which slows heat transfer better than air. And they have a vinyl frame, so the thermal bridge that we talked about earlier is slowed down a little bit more through the vinyl than if it was a wood frame. Then on the next pictures, you'll notice that we're also using sun tunnels to increase the amount of daylight. You can't have windows in every room and every hallway, so what we've done is we've put sun tunnels in the bathroom and one in the hallway to increase the daylighting there. And the way the sun tunnels work is it's not quite like a skylight, because the skylight you have to put in one place and that's where the light will come in. With the sun tunnel you can have the sun tunnel hole in the roof one place and then bring it down to where you need the light to be admitted inside the house, so it can do a little zigzag inside the attic space. Another way that the sun tunnel is better than the skylight for lighting is that inside the tunnel the light reflects a lot, so that it increases the amount of light that's admitted based on what's going in. So you're getting more light out of the sun tunnel than you would a skylight. And since we have all this great new equipment and products and ideas that we've put into this house, we have been creating a owner's manual for the house. And when I mentioned this to some friends, they thought this was a great idea and was like, why doesn't every house come with an owner's manual? And part of the reason that it's so great is that we all get owner's manuals for products that we buy, and we know there's a lot of information and it's hard to find the information you need, and when you find the information you need, it's not worded very clearly. So we've put together one manual that has the basic information about the house. So it's got information for the geothermal unit, basic maintenance, how it works, things like that. And then it's also got the concepts like daylighting and water saving to help the homeowners understand how their house is sustainable. And so it's got maintenance, and it's got maintenance for things like the concrete countertop and rain gardens, which are two products that don't come with owner's manuals. So even if we handed off all of the owner's manuals for all of the individual products that were purchased, they still wouldn't have the information about the countertops and the rain gardens. So we made up a manual with that information, the ideas of everything that's, all of the concepts that went into it, along with the information that isn't in an owner's manual. So they have the basic information that they can look at and get a grasp on kind of to begin with, and can reference back to it, but they'll also get all of the individual owner's manuals also, so that they'll know the specifics if they need anything.
Hi, I'm Jennifer Bowman, and I'd like to talk to you a little bit today about the collaboration that took place on this project. The main collaborators on this project were IPFW senior students in the Construction Engineering Technology Department, and also the Northeast Indiana Greenbuild Coalition and the Habitat for Humanity. The Northeast Indiana Greenbuild Coalition actually brought their expertise into our classroom to teach us about their different areas of what they were specific in. They had architects, engineers, and other construction design professionals there to train us on what we need to look for. We also, the Northeast Indiana Greenbuild Coalition, participated in the design charrette, and there too we also had design professionals available to us. This was a great real-world experience for the IPFW seniors. They actually got to experience working with design professionals, what is expected, how do you work with them, and the wide variety of ideas and concepts that you have to put together in order to form one project. Through working with Habitat for Humanity, the students were able to actually take all of their education and knowledge and technical skills that they have been taught over the last 4 years or so, and actually put them to work on a project that's actually going from design process and all the way through to the completion of a home, and even the construction that they got to work on. And that was actually a great experience for the students, because what you see on paper isn't always what happens out in the field, and they got to experience that and learn from mistakes that maybe were made, or how to design better and how to work better in the field with others and work as a team. Also through Habitat for Humanity, they would work as an owner's rep in the real field. So the students had to listen to what the family needs were, and then they had to design according to that within budget and with a sustainable design. And so there were a lot of goals to be met in this design. Habitat for Humanity also, in this collaboration, they benefited through, they've actually brought in their volunteer base, and these students can volunteer their time now. They understand what Habitat for Humanity is all about. A lot of people have the misconception that they're building, Habitat builds homes and gives them to people that need them. But that's a misconception. They actually have a mortgage, and through this process, the students actually learn a little bit about the process of becoming an owner of a Habitat home, and that they're actually working, the owner's actually working very hard to achieve acquiring this home. Also, they also benefit because these students will eventually be out in the field working for architects, engineers, construction companies, and that also gives the Habitat a larger base for donated materials, donated time, so it basically broadens that field for them. So they also benefit from this in a larger way than just on this one project. Also, through this process, Habitat and IPFW and the Northeast Greenbuild Coalition have all learned from each other and the students may learn what there is expected of them, and the Habitat and Northeast Indiana Greenville Coalition may learn what are the new processes coming out and being taught to the students, and may actually pick up some new ideas. So creating the sustainable home has been a great project for all that have been involved, and hopefully it will be continued in the future, and we can all benefit from it.